Hi, I'm Andrew Armstrong and welcome to the back office. I have a Boobie board here and quite a few of you at home do as well. Some of you don't know what to do with it. That's fair enough. That's my mistake because I didn't tell you how to do something with it. That's quite fortuitous because today though I am going to be doing something with this. So this is your Boobie board, just a quick overview. So you've got the voltage pins down the bottom. Sorry, let's start from scratch. Right, so it's a USB controlled device. You don't need it to be USB controlled, but the default firmware is. These are the programming pins here if you have your own PIC kit and you wish to use that. Here is an additional power jack socket. That's if you want to do something beefy, because the idea behind these is that they'll clip into some Veriboard or possibly breadboard and you can use it from there. So you have V in here. This is the power that's going to be coming from the jack. You have ground, you have 5 volts. This is the regulated power. Now you've got an adjuster here. It's a solder jumper and you can actually choose whether the power will come from the USB or from this. You can choose which one optionally. Also we have solder jumpers here to enable or disable the 40 megahertz crystal. By default it's disabled. So at the bottom here we have our various I/O pins. You can see they're labelled the same as the PIC datasheet. So this is a microchip PIC 16F688. So if you want to see what the pin function is, go look at the datasheet. They're all here. There's some with stars, and that means there's some sort of caveat in terms of multiplexing. So you can see here RC3 has a star on it because this is actually hooked up to an LED. So you have your own little LED you can turn on and off here. The RX and TX of course are multiplex because if you want them by default they'll be going through this FTDI232 chip for serial USB communication. You can actually cut these solder jumpers here and then use them for I/O if you wish to, if you don't need the serial side at all. RA3 is hooked up to the memory clear, so I believe that is an input only pin. It can't be used as an output. And RA4 and RA5 I don't recall, but we're going to use those. We're going to use those today as output pins. So we're going to use RA4, 5, and I believe RA0, 1, RA2 and RC0. You'll see. I'm going to hook them up as I go along. I'm just winging it, to be honest with you. And what I'm going to be hooking them up to is this 7-segment screen. So I'm really looking, I want a diagnostics port basically. I want something to tell me what's going on and I want it to flash on this screen. So these are, I believe, a common anode. So that means if I hook a positive to the common pin here, which is that one, and then I touch my, there you go. So that means, I'll show you, I've done a little diagram and everything. It's common anode, which means of course that the, need a pencil, VCC is common, and then you're syncing everything to ground. And how these work using this rather crude drawing is you've got various segments and they're marked as A, B, C, D, E, F and G. So they're sort of kind of a particular order you'll see on certain data sheets and a decimal point. And they sort of come out at the back here, and you have 2 common anodes here. You've got a VCC pin and a VCC pin, and then the other pins basically are those segments there. And what we're going to do is we're going to hook them up via a resistor to the microcontroller. So the microcontroller will be acting as these switches in this case, and you'll be able to operate this using the standard firmware that comes on the Boobie board. And what I'll be doing is writing a script on Windows probably just to talk to output every now and then information I need on this screen. So first things first though, I don't have, rather silly, I don't have decent pin headers or anything like that, so I'm going to see if there's any sensible way I could hook this up. I might need a bit of Veriboard. Okay, cut my piece of Veriboard, so I've got a kind of reasonable idea. I'm probably going to try to just mount it on top, just like that. So I'm going to solder these pin headers ultimately. I'm not going to do it right now, but ultimately I'm going to solder the pin headers, I think, I'm pretty sure actually, in this configuration. So just zoom in just to show you how I'm going to do that. So I've got these 3 going from 5 volts, RA5 and RA4. And then on this side and going from pins 10 to 15. So I've got from pins 4 to 5 right here, and then I'm going to go from pins 10 to 15. I'm pretty confident those are the configuration that we need for this. And then I'm going to just pop this piece of board, and I've cut the piece of variable so it's matching exactly the same pin count. So it's got the same 18 pins as a Boobie board. And I'm just going to flip that over to show you. So you've got the common anode there. So all I'm going to do on the back here is I'm going to solder this on. In fact, I can do that right now. And then I'm just going to cut the traces between the two sides, apart from this middle one, seeing as it's common anyway. And then I'll just show you how I'm going to hook that up. I'm just going to basically, from the other side, use resistors to pull across from the various pins over to where it should be onto the Boobie board. Haven't got quite the right resistors. I really ought to have something like more in the sort of 200 ohm range. I've got a 330. So it might come out a little bit dimmer than I'd expect, I'd hope, but we're going to try it anyway. We're just going to roll with what we've got. So let's just start with the soldering. The iron is on. Now you're going to ask yourself, or ask me, yeah, one segment, what good is one segment for? Well, for debugging work, one segment can be quite useful. But I agree, it's not, you know, it's not as useful as 2 or 4 segments. So I do have above me a different kind of driver basically in screen, where the screen is a common cathode. And that's a totally that they work in the sort of opposite way for this. So you can imagine the cathode of the LEDs are all joined. And then you've got basically a binary coded decimal to 7 segment driver chip, which I've got a bunch of up there. And you can they'll independently handle a lot of the communications to the panel, so you can actually drive multiple panels by sort of using chip select. But saying it starts to get a little bit more complicated when you're doing that. But this is just a basic proof of concept, really, of how the whole concept works. And if you want to understand this, or you will understand it by the time we're done, you'll have no trouble with those other things. And again, the Boobie board can quite easily drive those. So in the future, we can make one with as many as we want. We could do a sort of Back to the Future type panel if we want, with all of the different times and dates. Or you know, it could be useful just multiple diagnostic panels. So I'd quite like, for example, I'm going to use this one to try to tell me what's the CPU load on my computer. So when I'm rendering, I can just look over at any of my rendering machines and see what they're up to, just by using that, for example. You might have it collating how many emails you've got waiting for you, or how many tweets you've got. So there's lots of things you can do. But once you've got the whole end-to-end process of writing the script and getting the script working, you can do all sorts of things. I used to have it hooked up to Apache web server, so that over the web it could do stuff with Boobie boards, or move them, or interact with the sensors and things on them. So you can actually make your own little web-controlled gadgets if you want. Or you can use them even on something like a Raspberry Pi to just expand its functionality out. So I'm just double checking now, because we've got because of the way VariBoard works, and you've got tracking that goes all the way to the edges. Yeah, I'm just holding it up just to make sure that the edges that we have not cut away are not going to interfere. And looking at it, it's absolutely perfect for us as it stands. We get two pins here, actually hooking up already to outputs. We have these other 4 outputs which we'll bring across from the top using resistors, and we've got 1, 2, 3, 4, so that's nice. And then we've got 2 here on this side that we need to bring across to these 2 pins. And then we have this one, which is the 5-volt rail, which we'll have to bring across to this middle bit where we've got our common anode. And that should be it electrically. So I've cut away the sections here that we don't want. You can just see they're not done particularly well, but they're definitely not going to short anymore. So I'm just going to get the resistors now, and we're going to add those in. So we can, let's see, I think we want to go from here to any of these 4 pins at the top, excluding the middle. So I think it's easier though to sort of go all the way out. In fact, why don't I solder? No, I'll do that later. Let's get that on there, because you can see this pin header is going to be a bit tricky to solder. So I'm going to just mark where we want them. So our pins are going to be up to this line basically. So I think we're going to want that one there, that one there, that one there, and that one there. those 4. Rushing away. So that's going to be our first one. In fact, let me just get all of the resistors we need for this bank. Oh, my resistors, one of them's the wrong way round. How will I live with myself? So we're going to skip that anode there. So that's the first 4 in. And I might as well just put the last 2 in if I may. Just going to hold up. Just going to put the Boobie board under it so we can just check those pinouts while we're at it. So we want to go to RA5, which is this one, which is on pin 4. So we're going to go from pin 4 to pin 1. So I'm not really too bothered about the configuration of the pinouts and how they relate to the actual segments on the LCD, because we can handle all that in software. That's one of the benefits of using software on things. In the olden days, you'd have to have everything absolutely hooked up perfectly and worked out on paper. Nowadays we can cheat. We know we can, as long as electrically it's hooked up, we can just adjust it. So let's solder those LEDs in. I'm just going to try to put tack solders on these legs because I suspect they're going to move around. There we go. Just push that one through. Should do nicely. Just solder the other legs real quick. Come on, you cheeky so-and-so. There we go. Bit of advice. If you're using Veriboard, it does help to actually give it a little bit of a wipe down of either a very fine emery paper or some sort of board cleaner, just because they get a little bit of oxidization if you don't keep them in the bag, and it can be a bit hard to solder. But not a problem, they're done anyway. So just trim off any excess legs. We're going to probably use one of those legs for our power connection. Let's see if we can get a good long one. So we know we've got this power connection to make. Might use a bit of my tweezers here. So we're going to go from here through to here. Taking a bit of coercion because it's just such a short bit of wire. So I'm just going to solder that one. Just can see the tip of that one poking through. So there you go. So just hold this up so you can see the configuration. So we've got power here, and we've got 2 outputs from the pick here, and then we've got output, 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 output. 1, 2, 3, 4, 5, 6, 7, 8. So that's 7 segments plus the decimal point. So theoretically, we've got a battery here. We could test this. So let's put our positive onto that common there. And if we run the power supply underneath, oops, there we go. Making a good contact there. Strange, it's a little bit dim. Let's get a better connection. Right. So it is a little bit dim because of our resistors are that little bit too high, but then we're only running it from 3 volts here because it's a battery pack with 2 batteries. So you can see the connections there. So the pick will be basically sinking current on all these pins, and we'll get all those segments flashing. Okay, good. Now let's see if we can get these pin headers on in any useful way. Now the tricky thing is I kind of want to solder it so it's that way, which means I've got to solder the pin header on the wrong way round. So you can see what I mean. I'm trying to solder it actually from the bottom. So I'm just going to hold it like that. You can see I'm trying to get it mechanically just in there. Just a bit naughty. It's not how it's designed, but we'll manage. If you can get one, the rest will be easy enough. But it will fight you. Okay, so it looks like we've got one in there. Sort of. I'm just going to adjust. Ah, no. Just want to adjust it to make sure it's something we can live with when it's done. A bit more solder needed, I think. Okay. Yeah, that's looking pretty good like that. So I'm just going to go and touch up all the rest now. And then we can just tidy up that first one. So the first one's just like a tack. It's really horrible solder joint. But it just has to hold long enough for us to just get the rest done properly. Yeah, but they're flowing nicely now. Yeah, that doesn't look too bad. Even the first one more or less sorted itself out. Bit of extra. Yeah, clean that one up. Right, we have 3 more to do. I'm going to try a different technique on this one. This time I'm going to put a blob of solder like ready for it, and then I'm going to just sort of drop it in with some tweezers. May or may not work. Yeah, I think that's more or less worked. And before I sort of commit to that, let's just see we've got those all in the right place. Yeah, I think that's going to be okay. So I'll just finish off this one. So if you use pin headers, and you use pin header sockets on here instead, you could make this as a module that you can just push in and remove. I don't have any, so I'm just going to go for the rather inconvenient hard soldering everything in, but you can always desolder it later if you don't want it. It's not that big a deal. Just noticed something when I turn this around. The USB port here is touching the pins. So that's going to give us a short if we do that. So I'm going to trim the pins here on the LED module, and I'll probably, actually I'll just trim all of them, and I'll probably just put a bit of something there. And that something is going to be a bit of this foam, a bit of this 3M foam that we had lying around. It's a sort of self-adhesive foam. That'll go nicely, very nice indeed. straight there like that. And it's actually double-sided. It is an adhesive, so we could actually do that so it does stick on the USB port if we want. Might as well, bit of fun. I'll just put that back in there. So that's it sticking on in there. Just going to squeeze it till it's all nice and level. So there we go. So it's nice and level, uniform thickness. Let's just solder it in. Nice, these nice plated contacts on a Boobie board are actually quite good to solder, even if you've got it out for ages. They don't oxidize and mess up in the usual way a lot of things do. Almost there, just 2 more pins. If you're a stickler and you don't want to scratch anything up, you can just go and trim those pin header pins with some side cutters. Right, so that is our display module pretty much ready to go. We do have a USB wire that's going to be coming out the top of that, so that's, remember, they're going to have a wire. But we're ready. I think we can just go over to the PC now and start working out how we're going to program this. Phew, almost screwed up there. I forgot these 2 resistors, didn't I? The ones for the decimal point and this bit of the 7 segment. So yeah, don't forget those 2 resistors if you're making this circuit in exactly the same way that I am. Okay, let's crack on. I'm bloody lucky I discovered those 2 resistors. That would have been bad news. If you do that, by the way, you'll probably blow out the syncing ability of your PIC. So if your PIC port suddenly stops being able to sync currents on particular ports, you've blown it. Right, so I've got Device Manager up because I want to see what COM port it's come up as. COM12. You can see it right there, COM12. Let's put that aside. I'm using RealTerm, which is a SourceForge project. So go on SourceForge, type in RealTerm and you'll find it. But if you do, you might want to make a few settings. I'm going to show you those few settings actually, and I'll adjust my screen and everything while we're here. So I'm just going to give myself more rows to deal with. And look at, very annoyingly, every time you click the row button, the UI jumps. Let's try 25. And I'm going to change the font. I'll make that a bit bigger actually, because you boys and girls want to see that at home, I'm sure. And I'm going to change it to ANSI, because otherwise it will show all of the control characters. We don't want to see those. So put in a question mark. By the way, sometimes it does work, sometimes it doesn't. Because I've already used the Boobie board on this, you can see it's already defaulted to port 12, which is what we got in Device Manager. If it doesn't work for you, go into port, type in 12, and the baud rate 57600 probably will be preset there. And at the bottom of the screen, you'll see here where it says what your port and things are. So I've entered question mark and it's come up with a lovely screen, like a menu, a very happy, chirpy 8-bit style menu. So I'm going to push V first, type in V, hit return. Okay, so this is Angel Gabriel Booby, born on 9/46. So this will tell you your serial, effectively your serial number or your name of your Booby, and it's a random name generator, so some of them are a little bit odd. And the version number. Great. So that means he's talking to us. If you push D on the keyboard, you will see the pin configuration. And that's the pin numbering from left to right, looking at your Boobie board. If you look at it in the palm of your hand right now, you'll see pin 1 is on the left and pin 18 is on the right. So the pins between pins 4 and pins 15 are pins that do things that are sort of hooked directly or indirectly to the microcontroller. And you'll see there are some sort of reserved pins, like as I mentioned earlier, such as pins 7 and 8, which are RX and TX, and certain pins that can only be, say, inputs. So at the moment, they're all set to input. That's good. That means basically the Boobie there is sitting there passively, not going to be able to do anything. So this other menu options, you can configure the pin, that was D, L load config, S save config. So that's once you can change the direction of the pin. You can make them inputs or outputs, output high or output low. You can actually just save that configuration away. Next time you plug in your Boobie board, it will remember it and go straight into that. F is to format everything to defaults, which is pretty much what you see now when we push D. That's the formatted state. In fact, if I run it formatted, you can see it's the same state. X is reboot. And then these are the slightly more complicated commands, but not really very. So configure pin direction, that's the CPPDE, and you'll see the direction at the bottom of the asterisk says 0 is the input or 1 is an output. And PP is either a pin number from 0, 4 to 15. R is to read a pin's value, so if we say read pin 4, it'll tell you pin 4 value is 1, input. R pin 5 value is 1. Input. I wonder if they're all going to say their inputs. Let's try 9, 10, 11, 12. They've got no pull downs, weak or otherwise, so they're all going to say input. No problem. Write is to write a value to a pin. So normally this is for if the pin's an output. So you can write a 0 or 1. And that will set it to 0 will be a sinking source, that'll be 0 volts, or 1 setting it up towards VDD, which would be 5 volts in this case. And then pin interrupts are slightly more confusing, but what they do is if they're set on an input pin, when there's a change in state, it'll actually output to the screen right away. You won't have to poll it. So you won't have to do read 4, for example, polling. It will actually display when 4 has changed. So for our project though, you can see the LED screen in the top right corner. We're going to start messing with that. And to do that though, the first thing we need to do is actually set the directions of all the pins because of course they're all inputs. So the first thing we're going to do is we're going to say configure C041. Pin 4 is now an output and you see the LED. The LED on that 7-segment display has actually just changed. So we're going to do that for all of them. C051, where are we? 10, C11, C12, C13, C14, and C15. Bang! And they're all on. And what I can do now, if I just hit save, see, it saved the configuration. So if I just reboot the board, which is same as unplugging it, plug it in, but I'm just going to hit X, for example, you'll see that all the LEDs are on. They haven't gone away. It hasn't reset them to anything else. Great. That, though, isn't necessarily how we want it to come on in the powered state, but I'll tell you why it's doing that. So you can see that currently all of those pin values are off. So if you see 4 and 5, it says value off, off, 10, 11, 12, 13, and so on and so forth, off, 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 off. We don't want them off. So what we're going to do, we're going to actually change the values of those. And you can see I've just window popped up there. I've actually written scripts to do these, but I'm going to just show you them manually first, and then I'll show you how the scripts work. We're going to write to them. So example, we're going to do write 041. And you can see that's gone off now. And because if I then now do the D command, look at pin 4 as it stands before I hit the command. It says 4 output off. Now it says 4 output on. So we'll just repeat that with 10, 11, 12, 13, 14, and 15. And that's exactly what we want. And we're going to save that, save config. So that is essentially how it all works. Now let's take it to the next stage now. So you want to know how you're going to operate this, make it say something useful. And I'm going to show it to you in a moment, but using DOS batch scripts. So these are the kind of the worst way of doing it, but they definitely demonstrate how it all works. So you can see here, this is the common anode 7-segment screen we've got, and I've drawn the pinouts here. Well, not really. They actually are the pinouts because these are how the actual LED segments themselves are hooked up to the Boobie board via that 330 ohm resistor. So if I leave that here on the right, so that'll be just underneath the actual panel itself that you can see right on the screen. What you can see is, if I want to turn things on, I'm going to do, if I want to say make the character 7, I'm going to have to turn 14 to on. Well, I say on, I'm going to make it a sync current, so that'll be turning it on effectively. We want 15 and we want 10. And that's a 7. And that's basically how it all works. You just literally have a truth table and you look up the values for those pins, and what we're going to do, we're just individually going to turn them on and off till we get the character we want. So probably the most annoying one's going to be an 8, because an 8 is basically everything on. So we're going to have to do... actually, before we do that, well, go on, all right. And W050. One more actually, there, 8. And we've got a decimal point there. Do you want the decimal point? Ding. So that's basically how it all works. So what I've done, I've found a program that you can get online. It does simplify things a little bit. I'm just going to find it for you. Here it is. It's called Serial Send. And it's from this batchloaf.wordpress.com/serial send, and I'll probably be adding this to my own repository, so I'll have links to where you can find this. And what it allows you to do is bring up your DOS command batch file, and you can then write these serial commands. Instead of using this program here like this, you can actually write them directly. So before we do that though, I just want to set it into a clean state. So tell you what, let's reboot. So everything is all off now. And we're going to shut this down. So we're no longer going to use real term. We're going to do everything from the batch file, the DOS command line. And you get that in Windows by going down here and typing CMD. See it there? Command prompt. And then you've got to go find where you've put your files by using CD and various commands like that. If you need help, please let me know. We could help you with some of those DOS things, but there's plenty of tutorials online. And you'll see a bunch of files in here though. I want you to sort of ignore those for now. I just want to show you how to use the serial send command. So it's serial send.exe and it's baud rate 57600/dev_num, and remember we were com12. And then we need something because we want to send some control codes. We need a hex there, and that's pretty much it. So if we want to turn a character on, like the middle bar, which was 12, we're going to say W12 0. Do you remember that? /R/N. So what this is effectively doing, it's like as if you're typing in W120. And /R/N is the control code that's sent when you hit the return key on your keyboard. So when we run this, it should execute it as if you've typed it in yourself in the terminal. And there you go, the bar comes on. And tells you a bit of bump. You can see here it's specifying the baud rate, finding the serial port, sending the text, and then closing the serial port. So all that does take a lot longer than doing it from a normal program. But we're not going to cover that in this little tutorial. We're just going to do everything on the serial port till we're all happy and familiar with it all, and we can write some very clever but cumbersome batch files to do lots of things. So you can see you can just keep building up on this by just sending the different commands, and away you go basically. I tried to write to 17, which obviously doesn't exist, and then you can just keep going with it. Let's do one more. 13. There we go. 13 and 50. So by the way, look, you can make all sorts of characters which can't exist in real life. In fact, I'm going to do one right now because I've just noticed something, that when my cooker says there's something off the hob, it's an inductive hob, and if it detects the pan is off the hob, it shows that one. So what you can do then is you can create a batch file. So I have created a batch file, so I'm going to run one for you called initialize. So initialize.bat. I'm going to run that, and oh yes, it does take a parameter. I have to put in 12 because that is the COM port number, and it will run along. And that's basically now. I'm just going to see, by the way, if I can make the terminal a little bit bigger, the font. Oh, I can. I do apologize, boys and girls. You could have been staring at this at ease, basically. Oh crikey, it's a monster of one. Maybe that's a little bit too big, but there we go. So now we've got that all in, I'm going to show you what it does. So initialize, if I bring initialize up on the screen, what it does, I can't increase the font size on this probably. Oh, I can. Right, excellent. What it does, it's basically, if I get the echo off, is just a DOS thing that just stops the commands getting printed on the screen. It takes the parameter, the first parameter you give it is the COM port, so that's why I'm typing 12 after everything, because that's the COM12. And it's basically just running through a bunch of commands as if I've typed them in on the command line. So what this one does is set the direction for all the pins to be outputs. Remember we typed that in? At the moment our Boobie board actually is remembering that config because we saved that as its default. So really you don't need to run initialize, but I'm going to include it there. So if you're running this at home, you can use it to sort of configure your system to something, into a known state. So we've got, I'm going to run it again to show you what happens. Initialize 12 because we're on COM port 12. And it runs through and it's initializing it. You're not seeing anything though because the Boobie board has all those pins already set to outputs. But you will see something if I type in all on 12. And now you can see it's turned on all the LEDs. And I've got another one called all off. Oops, see that's what happens if you forget the 12. And off they go, and it does them step by step, so that's why it's got that rather nice effect of them blending away. So you say, what else can I do with this? Well, theoretically you can come up with different numbers. So if you take something, I'm gonna create one for you. Let's see if we can do the number, I don't know, 2 for example. So we've got the thing that turns it all off. I'm just going to do copy all off.bat to 2.bat. So I'm going to make a batch file called 2. Notepad 2.bat. Okay, so you can see this turns off all of the pins, so it goes back to 0. But if we want to make a 2, you can see we want to keep on number 14, 15, 12, 4, and 5. So I'm just going to look through the codes. I'm going to find 14 and I'm going to say actually I want that on by setting this last parameter to a 0. I want 14, I want 15, I would like 12, I would like 4, if I can find you, 4, and I would like 5. And there we go, that's 5. Save that. I'm going to close that. I know it's going to work. I'm going to add 2 port 12 for COM12, so hopefully this will say 2 when we're done. Ah, look at that, 2. And once you've done that for 2, you can do that for everything. So I've got a 1, I've got a 3, I've got a 4, 5, 6, a sizz, 6. There we go. 7, 8, 9, and of course we don't have a 10, but we do have a 0. And if you want the decimal point, I've got another one, DP on. You can turn the decimal point on or DP off independently. And then once you're done, all off. So that's basically how you do it. So each of those is a separate batch file, and they're all about the same size because they're all executing roughly the same number of lines, and that's pretty much it. So I'm going to include all of this folder basically with all of these files, all the batch files, everything like that on my GitHub, the Back Office Show GitHub, which will be linked to probably in the comments of this video and off my main website. So if you want to build this yourself, I'm going to include the serialsend.exe if it allows me, and just to sort of remind you where that's from this chap, and I don't want to take credit for their code, but there's the C source code if you want to sort of write your own. And what I would suggest to you, those of you with the Boobie boards and know how to do a bit of C programming, you can make this a lot faster, because when you see it going in and out through the different numbers, like, you know, if I'm going to just, for example, run all on 12, you'll see it's doing it very slowly. It's taking a lot of time. You can actually get it to a lot faster inside the code because it doesn't have to load up the COM port and shut the COM port down every time if you're doing that yourself. So I hope that's of some use to you. I hope you've enjoyed playing with your boobies. And if you've got any comments or questions, please feel free to ask me down below through Patreon or Twitter. Patreon or Twitter, wherever you can get hold of me, I'm happy to answer you. If you need more Boobie boards, of course, backofficeshow.com/shop. As ever, thanks for watching.